Hi, welcome to our poster presentation. Today we'll be discussing exploring improving fleet utilization through a comprehensive analysis of shipment brokerage market entry. Our team consists of myself, Austin, Abhiram, Aditya, Melanie, and Hammad. Our client is a large food processor with a large truck-focused supply chain, and they want to look at the feasibility of building a brokerage firm to recover lost utilization from deadheads. When it comes to shipping with trucks, there are three types of travel: head hauls, deadheads, and backhauls. As we can see in the diagram, a head haul is when a truck loaded with product goes from an origin point A to a destination point B. A deadhead is when that same truck comes back from B to A empty. These are bad as they don't add any value to the supply chain and cost money. A backhaul is when a deadhead is filled with a product from a company close to B and then delivered to a company close to A. This allows a shipper to fill empty miles with a revenue generating trip. Now that we have this understanding of industry in place, we can talk about the methods for conducting the financial analysis.
To see whether there is a financial feasibility for our client to build a brokerage company to reduce deadheads, we came up with this methodological diagram. We gathered two groups of data. One is for the calculation of deadheads and the revenue generated by them, and the other is for the calculation of costs for building a brokerage company. So after calculating these two groups of data, we got two estimators. One is the projected revenue and the other is the projected cost. We combined these two data and to draw a cash flow diagram to see whether we should recommend our client to build a brokerage company. To start, we conducted EDA by using social net analysis to see what cities have a high number of incoming and outgoing deadheads. We use betweenness as a measure of the centrality of locations. The definition of betweenness is how often a location occurs on all shortest paths between two locations. We can see from the graph that Greenfield has the highest number of deadheads, followed by Monmouth, Tar Heel, Junction City, and Kansas City.
We were lucky to have access to data that provided us with multiple angles to approach solving the problem. The approach we took considered these variables. There were a few data points where origin and destination names were spelled differently and a few international locations. So we made corrections and used Google API to derive geolocations of the places, which helped us determine distances between all the combinations. Some shipments have multiple stages, meaning one truck delivering shipments to numerous locations in one trip. However, only the final drop-off determines the deadhead start point and therefore the distance. So we reduced those and considered only the last stage. For a combination of origin and destination, we aggregated the number of scheduled outbound and inbounds on a weekly granularity. The resultant difference is the number of deadheads from that destination to the origin. This is a conservative estimate of the number of deadheads. To estimate opportunity, we considered miles traveled from the Google API, demand and revenue from our client's DAT system. A safety factor of 0.7 is chosen, assuming only 70% of this demand will be met. This resulted in a total opportunity of $9 million.
So as we got the revenue covered now, we need to establish the cost that will be incurred while building a brokerage firm. So we have 6 different categories of operating costs. If you look at the diagram, the first category is the employees who will be working for the firm. We also have taken into consideration the travel, benefits, and the bonuses. We also have allocated a budget to renting space and hardware supplies for our firm. One of the major drivers of the cost will be the TMS software system, which will be the backbone of our firm. This system will be helpful in optimizing our logistics. Lastly, to make sure our firm is compliant with federal and state regulations and to make sure we mitigate risks, we have also taken into account the cost for legal services, and this team will help us with compliance agreements and liability protections. We also have insurance and licensing fee. Some of the business insurance for a freight brokerage firm include cargo liability insurance, auto and general liability insurance, and the umbrella liability insurance. Now, deep diving into the organizational structure of our firm, As we see in the diagram, we have come up with 4 major departments, namely the HR department, the finance department, the operations department, and the IT department. These 4 departments will work closely with the brokerage manager, who will manage the end-to-end business functions.
Once we had all the costs and revenues figured out, we were able to put together the feasibility analysis. We used NPV for our financial model with a time horizon of 5 years. We used Excel to model all the costs and change rates, leaving the model parameters open for the client to change as they see fit. Using our very conservative model, we found the break-even point in year 4. Our 5-year ROI came out to around 12%. With these numbers in mind, we gave a very strong recommendation to our client to pursue building the brokerage company, a recommendation they were very happy to take. Thank you for your time.